Hey, what's up? Question. So I was trying to download the ANSYS.
Okay.
And so when I extracted it, it would go here.
Yep.
And then I would run as administrator.
Mhm.
And then I would get an error once so it'll run it, and then I accept, and then it goes like 30 seconds, and it says critical error, and it just goes like that.
Oh,
And I tried deleting the entire file,
Yeah.
re-downloading it,
Yeah.
did about like 4 times.
still.
Yeah,
Oh.
so I don't know if this is maybe me.
Oh, I wonder if it is a fairly hefty program. So I don't know if there's maybe it's finding of mistakes.
I deleted like a bunch, I had like almost like 100 gigabytes.
Oh, yeah, that's
Still, so
That's really
I
weird.
think it's only like 16 or 17. So it works right now, then you want magic.
That's the thing with computer, as soon as you show someone, then it will work.
Yeah.
Magic.
Try to see the log, like what it's even doing,
Yeah.
and so it does that, and then it'll just tell you when you have, no, it won't even.
It's the worst.
And then it just stays like that.
Someone like
I was like, well, maybe I'm just impatient, and it was like 20 minutes. Yeah,
it's doing like.
I mean, I think it's 21. Keep trying to, I said, I've never seen that before.
No, I haven't.
I was like, oh.
Yeah, I mean, I guess the only sort of people ask me is support.
I mean, I'm trying to do it on my desktop.
Like we like to check.
Okay.
Nah.
Okay, I mean, for today, I mean, you can, this.
Yeah, I can always like,
Yeah.
I just figured for home, but
Yeah.
about to do it on my desktop.
Okay.
You're the first teacher.
Yeah.
Yeah, I was thinking on the way here, just drive off the road.
Making my turn.
Yep.
How you doing?
Good, how are you?
A little tired.
Oh, yeah, no, I'm already sleepy. I miss being able to nap at any time during the day.
Oh, yeah. No worries. No way.
I saw that, and like, I gave that impassioned speech about AI, and then like, school was like, here's the AI. whatever we use."
Give you a free membership to it.
Dr. Chang can use the summer reports from the school.
No, still no. I don't.
Sorry.
Yeah, I know. There's no like, yeah, I mean, they basically said everyone just do your own thing. Some actual leadership would be nice. That's too much to ask.
Have we tried to grade an assignment with it? Dr. Trump,
What's
have
up?
we tried to grade an assignment with it?
No,
Like the South Park episode,
no.
they're like grading assignments and doing their like homework with it. Like one of the teachers was like grading all the assignments with it.
Oh, really?
And he's like, oh, this is good, like, hopefully the students don't find this. Like, but they were using it too.
I've heard some high school teachers grading with it.
Yeah.
I heard a case where like the high school teacher had the students write, basically like our first homework, like introduce yourself. He had the AI grade it, and no one got a perfect score. on the- So the AI knows you better than you. You didn't write a good enough introduction to yourself. I heard that, I'm like, no, I'm never using this. All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today?
Okay.
Good, okay, hanging in there. This week, still week one, but we got a long semester to go. All right, but today is an exciting day. So today is our first activity in ANSYS. So if you've taken a previous finite element class with me before, this semester I think will be more enjoyable because it's kind of a constant stream of ANSYS. Basically every other week, we'll be doing an ANSYS activity. But also, if you've taken it before, this activity is probably very familiar. So it's my first activity that I've been using for 5 years now. It's the same friggin' plate with the same friggin' hole. So, we're gonna be doing this again. But If you haven't seen ANSYS before, I think this will be a good experience. This is kind of the traditional first thing that we do. Okay. All right, so let me just introduce the situation to you. So in this ANSYS activity, we're going to be simulating this. It's a metal plate. There is a hole that's cut out of the middle of the plate. Okay. On one side of the plate, we're going to fix it to a wall, and so we're going to apply a fixed boundary condition on the left-hand side. And on the right-hand side, we're going to be applying a tensile force in the form of a pressure. Okay. And what that's going to do, so let me go ahead and scroll ahead just so that you can see. Okay. What that's going to do is that it's going to cause the plate to deform. And so you can see here that we have a little bowing action here. Okay. And it's also going to cause structural stresses to occur as well. Okay. So we'll be going through the whole process today of how to even just basics of just booting up ANSYS, what you're looking at, all of the interfaces, because ANSYS is not the most user friendly. It's very feature packed. But sometimes sifting through all those features and getting to the part where you need can be a little bit difficult. So we'll be going through that today. This is kind of just first exposure to ANSYS, and so if you have no experience with ANSYS, this is going to be great. If you've seen this before, if you've used ANSYS before, just kind of follow along. Okay, and so the due date for this activity is going to be next Friday, January 31st. Okay. So we'll be doing it today, and actually, I think most people will be able to get pretty much the entire activity done today. But of course, whatever you don't finish, you can finish up for another week. Okay. Okay. Any questions on anything before we get started for today? Yeah.
Does ANSYS installed in this computer?
Yes, they should be. Yeah.
Find that?
Yeah. So that is the first thing we're going to do. So finding ANSYS is not the most straightforward. We'll open it together. Yeah. Any other questions before we get started? Okay, all right, so let's go ahead and get started. So first thing we're going to do is we're going to open up ANSYS, okay? Now ANSYS, if you actually look and see, if you had a chance to install it on your own computers, you'll see that ANSYS is actually a collection of, a dozen or so different programs all kind of meshed together. So to actually open up ANSYS, we need to open what's called the manager program, okay? So the manager program in ANSYS is actually called Workbench. And so if you're on a Windows machine like this, you can search up Workbench, okay, or just type work, okay. And then hopefully it should pull up the application for you, okay. So the lab computers here, just because we renewed our license back in August of last year, so it should be 2024 R1. But I think the most recent student version online is 2025 R1. But there's really no difference in between the versions, at least for what we're going to be using. All the features are going to be the same. The only issue that you may be having is if you're going to be switching between versions. So let's say you start working on something in the class, and then you take it home, you work in 2025. Just like SolidWorks, you could upgrade. So you can take your 2024 files and open it up in 2025. You cannot do the reverse. And so you can't start something at home. You can't start something in the 2025 version and bring it back to 2024. It only goes kind of one direction. Okay, so let's go ahead and open it. All the computers here should have it working. We just renewed the license back in August, and so they're usually good for a year. But if you're having trouble opening ANSYS, just raise your hand. I'll come to that. Okay. All right. So when you boot up Workbench, you should get a window that looks like the following. Okay. So it should be mostly blank, but there are some menus on the side and on the top, and we'll go over all of those. Yeah. Okay. Okay. All right. So was everyone able to open up ANSYS Workbench? Maybe I'll give it maybe 10 more seconds for people to boot up. Okay. Okay. Good. Okay. So let's take a tour of this kind of window as it is right now. Okay. So first thing to notice, and it's a little bit hard to see because the Zoom thing is in the way. Let's come to the top here. Okay. So on the very top here, we have our very kind of standard Windows, toolbar here. So we have File, So here you can have, you'll see options here for saving and loading projects. We have the view here, so, we'll be looking at this a couple times if you need to reset your view and other things as well, okay? Of course, the most important thing here is the file, okay? So, before we start here, let's go ahead and save our projects. Let's go ahead and click Save As. Okay. You can save this wherever on your current desktop, or you can, choose a place which is most convenient for you, okay? Let me go ahead and save this to Documents, okay? You can go ahead and give your project a name. One thing that ANSYS is kind of very finicky about is that it doesn't like spaces in the file name, okay? So if you're going to give it a name, if you want to put spaces in the name, you have to replace the spaces with underscores, okay? So I'm going to call this ANSYS underscore activity underscore 1. And you can put your name. So I'll put JST for my name. Okay. Okay, so then go ahead and click Save. So remember, no spaces in the name. ANSYS actually does not like that at all. Okay, I'll go ahead and click Save. Now our project is saved. So that's good. Okay. Okay, so up here is pretty standard, just saving and opening, and we'll go, and at the end of class today, we'll go over how to actually export your project and bring it home. Okay. Next thing we're going to look at here is on the left-hand side. So on the left-hand side here, we have, you can see the name of this box here is called the toolbox. And this is where you can find all of the different analysis systems that ANSYS is capable of doing, okay? So the thing with ANSYS is that it's a very general software, so you can do lots of different types of analysis within ANSYS. In this class, we're mostly going to focus on structural simulations, so applying forces, applying fixed constraints, pressures, and seeing how an object deforms. Okay. But actually, finite elements is actually a very general methodology, so you can actually solve for things like fluid flow, right? So there's actually quite a few tools for fluid flow here. There, you can do heat transfer simulations. So there is steady state thermal, and I think transient thermal as well. Okay. You can do vibration analysis. You can do modal analysis, which is finding the harmonic frequencies. Okay. Eigenvalue buckling, dynamics, a lot of different stuff here. Okay. For the most part, at least, especially for the first part of this class right here, we're going to focus just on one analysis system, which is static structural. And what that basically means is that, we're going to be solving the equations of statics. And so, we have an object where there's no motion involved. We're going to apply a force, and we're going to see how that object, deforms in response to that force. Okay. Basically, we're going to be solving for the equilibrium state of a particular structure. Okay. Okay. So to activate an analysis system in your project, you can do it one or two ways. You can go to static structure right here, and you can double click. Okay. And so if you double click, it's going to bring static structural here to the project schematic. Or what I like to do is I like to take static structural, click and hold, and then drag that into the project schematic just like that. Okay. Okay. And then from there, it's going to create a new kind of static structural system for you. Okay. And you can see here the ANSYS kind of lays it out kind of nicely, where it shows you kind of step by step how to complete this analysis. And so first, we're going to specify the engineering data, then the geometry, then do the model and setup, and then look at the result of the solution. Okay. Okay, so was everyone able to find static structural and get it into the project schematic just like that? Okay, okay, cool. All right, so next thing we're going to do before we define the geometry is let's go ahead and well, let's set some properties for our simulations first. Okay. So this next step, usually we're not going to do this because, for the most part, we're going to be doing 3D simulations. This activity is a little bit unique because it's a 2D jump. And so we want to make sure we tell ANSYS that it's 2D. And so to tell ANSYS that we're doing a 2D simulation, you're going to right click on engineering data, and then you're going to go to properties. Okay. And then after you click on properties, it's going to open up a new window on the right-hand side of the screen. Okay. So I'm going to go ahead and click properties. Oh, sorry, you need to right click on geometry. Okay. But if you already right click properties and you click geometry, it should be here. Okay. So if you right click geometry, click properties, it should open up this menu here on the right-hand side. Okay. we're gonna go to one particular line right here, which should be line 19 for analysis type, okay? So right now it's set to 3D because 3D is the default, but we're gonna go ahead and change this to 2D. Okay, so again, in most cases, you're not going to have to do this, but this activity is just a little bit special because it's a 2D analysis. Okay. Okay. All right. Next thing we're going to do before we make the geometry, let's go ahead and specify our material properties. Okay. So remember, we talked about on Tuesday that material properties is an important part of every FEA simulation because it defines, how your structure is going to deform. So to define the material properties, we're going to double click on this, this entry right here called engineering data. So let's go ahead and double click on that. Okay. And it's going to be a little bit disorienting because it's going to change your entire screen here, but it's going to bring up the material window here. Okay. Okay. So first thing we're going to look at here is just kind of the outline of the different materials that we have. Okay. So you can see here that we have just one material loaded right now, which is structural steel, okay? Okay. But if you wanted to add multiple materials to your simulation, then you would be able to add it up here, okay? Next place we're going to look at is in the bottom middle of the screen, which is going to show you all of the numerical properties of that material, okay? And so you can see from this window here, these are the properties for structural steel, okay? Okay. So for our cases, and so let me bring back the project specifications for a second, okay? And so we want to make sure that all of the material properties are consistent with this, for this material here, okay? So for this material, we want a Young's modulus of 2 times 10 to the 5th megapascal, okay? And we want a Poisson's ratio of 0.3. Okay, so these are the two material properties we want to make sure that we, that we have loaded for our project. Okay, so let's come back to a workbench here. Okay, and let's look at the Young's modulus and let's look at the Poisson's ratio. Okay, so the Young's modulus for structural steel you can see is 2 times 10 to the 11th Pascal, and the Poisson's ratio is 0.3. Okay. Now we can see right away that the Poisson's ratio is what it needs to be, is 0.3. The Young's modulus is actually correct too. It's just that it's in the wrong units here. Okay. So by default, ANSYS here will display everything in just kind of standard SI units. And so SI unit for Young's modulus is Pascal. But if you want to display this in megapascal, you can come to this drop-down menu here. Okay. This will let you convert that Young's modulus to different units. So let's go ahead and convert this to megapascal, just so that we can kind of check that it's the right one. Okay. And so when we change the units to megapascal, you can see our value updated here to 2 times 10 to the 5th. Okay. And that is exactly the Young's modulus that we have. Okay. So in this case, so for this project, we're not going to be doing any changes to the material properties, but we are going to do this for activity 2. Okay. But I just kind of wanted to show you where this was for this project. Okay, any questions on the material properties? Okay, cool. Okay, so when you're done with the material properties and you kind of verify that everything is good here, we can go ahead and close out of this window. So if you go to kind of the top of the screen here, you can see that there's a couple tabs here. Okay, we want to close the tab for engineering data and kind of bring back our menu here for our project. Okay, so next step that we have here is we're going to construct the geometry. So again, this part here is a little bit unique because usually we're not going to be constructing the geometry ourselves, but since this one is so simple that we're just going to do it from scratch. Okay. Also, one of the activities at the end that you're going to work on your own is I want you guys to modify your geometries. That's only possible if we kind of make it ourselves. Okay. Okay, so to create a new geometry, you're going to right-click on geometry from the project window, and then you're going to click on new design model or geometry. So let's go ahead and do that. And that's going to open up a new window here, which is going to be a separate program that ANSYS runs. ANSYS, member is kind of a collection of a dozen or so different programs, and Design Modeler is one of those programs. Okay. So was everyone able to open up Design Modeler? Everyone's seeing this window here? Cool. Okay. So let's go ahead and draw our plate here. So our plate has a fairly simple geometry. It's just a rectangle. Okay. We have the dimensions of the rectangle here. So the length of the rectangle is 300 millimeters. The width is 200 millimeters. The thickness, and so that's the thickness of the plate going into the page, is 5 millimeters. And the diameter of the hole is 50 millimeters. Okay. Okay, so first thing we need to do is we need to draw our sketch. So you can draw the sketch in any of the 3 principal planes that you want. But I think it's kind of easiest to sketch things in the XY plane. So let's go ahead and click XY here. And you can see, the XY axes show up here. Okay. Let's change the viewpoint. So let's change the viewpoint so that we're looking kind of straight onto the XY plane. And so the easiest way to do that is to click on the Z arrow in the bottom right-hand side of the screen. Okay. So we click on that Z arrow, you're going to see that our perspective is going to shift. So now we're looking straight down the Z axis. And we're kind of, we're kind of parallel with the XY axis here. Okay. All right, so to start sketching, you're going to come to the left-hand side of the screen right here. So you can see that there's kind of a small tab here called sketching. And this thing's kind of in the way here. Okay. So let's go ahead and click on that tab right there. Okay. And so this is going to open up a set of kind of very basic shapes that you can draw. Okay. Oh, actually, before you start drawing, let's make kind of one important change just to make things a bit easier for you. Okay. So we're going to come up to the top right here. So you can see that there's one entry at the top here called units. And we want to first change our units here to something that is kind of convenient for us. Okay. So the default here is to define everything in terms of meters. But since our dimensions in the PDF are given to us in millimeters, let's go ahead and change the dimensions here to millimeters. Okay. I'm going to click on units, go to millimeter. Okay. Now everything that we do is in terms of millimeters. And so that'll make things a bit easier for us when we dimension. Okay, so first thing I'm going to do here is I'm going to draw a rectangle. So I'm going to click on rectangle. Okay. That's going to change the cursor here to kind of a pen. And so you're going to click once to draw one corner of the rectangle. Okay. You're going to click and drag. You want to make sure that you encompass the origin, just to make things a bit easier for you. Okay. Then when you're satisfied with your rectangle, you can go ahead and click again. Okay. Don't worry about sizing it just yet. We're going to apply dimensions to this ourselves. Okay. But you just want to make sure that the rectangle is out. Okay. Okay. Good. Bless you. Okay, so I'm gonna go ahead and clear the my sketches. Okay. All right, so next thing we're going to do is we're going to dimension this rectangle to make sure it has the appropriate height or appropriate length and appropriate width. Okay. So to dimension a shape here, you're going to click on dimensions. Okay. So let's go ahead and do that. So that's going to change the menu here. So with the dimensions, window here, just like you've probably used in SolidWorks, is that it's going to help us specify the lengths of certain edges of our geometry. Okay. So we're going to use the general tool. So click on general here. Okay. And in the window here, you're going to click on one edge of the rectangle. Okay. You're going to click on it to indicate that you want to specify dimension there. And you're going to click and drag a little bit outwards and then click again. Okay. So you can see here we've created this new dimension called H1. It's kind of hard to see. Okay. Now we can actually specify the length of that side. Okay. Now this is probably going to be a little bit different for those of you who are used to SolidWorks. Normally in SolidWorks you can define the dimension straight in the window right here. But for this case, but for ANSYS, you actually specify the dimension in the bottom left-hand side of the screen. Okay. And so if you look at the correspondence, you can see that we have our variable or our dimension H1. And right now it's set to 96.387 millimeters. Okay. So let's go ahead and change this. And so from our document here, we know that the horizontal length of the rectangle is 300 millimeters. So let's go ahead and change this length to 300. Okay. So go ahead and hit 300 in your keyboard and hit enter. And you can see that now the length of our rectangle has changed quite a bit. Okay. By the way, if you want to pan the screen, if you want to kind of slide it back and forth, it's a little bit non-intuitive, but the way you do it is you hold Control on your keyboard, and then you hold down the middle click on your mouse. Okay, so that's how you can kind of drag it left and right. Okay. Because if you don't do that, then you're going to rotate, which is not useful. And so you want to make sure you hold Control and then hold the middle click. Okay, so we've gone ahead and set the dimension for the length. Let's go ahead and set the dimension for the height as well. Okay, so just like we did before, make sure we have our general dimension tool selected. Click on the vertical edge of the rectangle, drag it out. Okay, let me clear my drawings here. Okay, so we've created a new variable here called v2, and we're going to set that dimension equal to 200. Okay, so once again, we're going to do, hit 200 and then hit enter. All right, so now our rectangle is the appropriate size. Last thing we're going to do before we draw our hole is to just make sure that it's centered on the origin. Any questions on this so far? Good. Okay, next, let's use the dimensioning tool to center this rectangle on the origin, because right now it's kind of off center. Okay, so to center the rectangle on the origin, we're going to make use of these other dimensioning tools. Okay, so let's make use of the horizontal one first. So what the horizontal dimensioning tool will do is that it specifies that two features of your geometry are separated by a certain distance. Okay, and so the two features that we want to separate are, let's say we click on one of the vertical edges of the rectangle, and then let's also click the y-axis. Okay. So you can see that's allowing us to specify the horizontal distance in between those two features here. Okay. And we want to set that to be half of the length. Okay. So you can see we've created a new variable h3 here. So we set that to 150. Okay. That's going to center the rectangle on the at least from left to right. Okay. And remember, you can only do that with the horizontal dimensioning tool selected. So let's do the same thing with the vertical tool. So let's click on vertical dimensioning. Okay. Click on one of the horizontal edges of the rectangle, and then click on the x-axis. Okay, so we want to specify the vertical distance between those two lines. Okay. Right. And then just like we did with the previous one, let's set that to be half of the height. Half of 200 is 100, so let's click 100. Okay. And now we have our rectangle that's centered on the, okay, so it has the appropriate length, the appropriate width, it's centered. So now we can go ahead and draw our hole. Okay. Okay. So let's go ahead and draw our hole here, right? So the reason we did this is to make it a bit simpler, because you can go back to our diagram here. The hole, is centered on the plate. So we want to make sure we draw the hole in the appropriate spot. Okay. Coming back to ANSYS Design Model, you want to go back to the Draw tab. Okay. So Draw tab, come back up here. We're gonna draw a circle this time. So go ahead and click on Circle. Okay. You're gonna come to the origin. Your mouse should snap to the origin because it is a point of interest. Okay. You're gonna click once on the origin. That's gonna let you start drawing the circle, and then you can click and drag outwards to change the size of the circle. Okay. Again, don't stress too much about the size. We're going to dimension it in a second. You just need to have the circle there. Okay. So we've gone ahead and drawn our circle. Let's go ahead and dimension it. Let's go back to the dimension tab. Click on General. Okay. You can click anywhere on the circle. So if you click anywhere on the circle, it's going to let you specify the diameter. Okay. So go ahead and click again. That creates our fifth dimension here, D5. And let me double check the diameter. Diameter of the circle is 50 millimeters. So let's specify this as 50. Okay. All right, and so that is our sketch for our plate with the hole. Any questions so far? Okay, cool. All right, so let's go ahead and turn this into a solid here, okay? So to turn this into a solid, let's go ahead and when you're all done with dimensioning the circle, let's go back to the modeling tab here. So click on modeling right there. Okay. Right. If you expand the menu for the XY plane, you can see that we have one sketch, and so that's the one that we kind of just drew. Okay. So to turn this into a solid, you're going to come up to concepts here. Okay. So you're going to come up to the very top menu here. And under concepts, you'll see that there is an option called surface from sketches. Okay. And so that's what we want. We want to turn this sketch into a surface. So go ahead and click on this. Okay. And so you're going to see it's going to create a new object in the tree outline here called surface SK1. Okay. So let's go ahead and click on that. Inside the surface SK1 is going to ask you to define what's called a base object. Okay. And so the base object for our operation here is going to be the sketch that we just drew. So go ahead and click on sketch 1. Make sure that's highlighted, and then click on apply in the bottom left here. Okay. So then what that's going to do is that it's going to change the base object for our operation to sketch one sketch. Okay. The next thing we're going to do is we're going to specify a thickness, and so remember thickness is going to be the thickness of the plate in the Z direction here. Okay. If we come back to our PDF here, we can see that the thickness we need to specify is 5 millimeters. And so let's go ahead and do that. Okay. So under the option for thickness here, we're going to specify this as 5 millimeters. Okay. And then when all that's done, you're going to go up to the middle of the screen. So there should be a yellow lightning bolt that says generate. So let's go ahead and click generate. Okay. And doing that will produce your plate. Okay. Now it should be very thin. That was kind of the point. It only has a thickness of 5 millimeters, but you should see that the plate should be filled out in the parts where it's solid. Okay. Okay. Any questions on this? Everyone able to get our plate with the hole here? Okay. All right. And so if you've constructed your plate here, it is nice and solid. You can go ahead and close Design Modeler. Okay. Now you want to be careful here. Don't close Workbench. You just want to close Design Modeler. So they are separate windows. Okay. If you're paranoid like me, you can minimize Design Modeler and then click the X here so the X's aren't overlapping each other. I've totally done that. You know, a lot of times where I've closed the wrong window. Okay. Go ahead and hit save. Okay. Just to make sure that your geometry is saved here. Okay. And if you did everything correctly, you know, what you should see is that the geometry portion of your project should now have a green check mark. Okay. So that's ANSYS telling you that, you know, your geometry is good. Okay. In fact, this is a convention that ANSYS uses a lot. And so, you know, you're going to see these green check marks quite a bit. And so when you see a green check mark, that means it's usually good. Okay. Okay. So to actually run the simulation, we need to open a separate program called ANSYS Mechanical. And the best way to open that is to double click on model here. Okay. So if you look at this list here, you see model is kind of the next step in the list, and there is kind of a green kind of refresh mark there. So let's go ahead and double click this. And that's going to open up another program. By the way, if you're not sure if ANSYS is actually working or not, or if you clicked on something, if you look on the bottom left-hand side of the screen, if ANSYS is working on something, it'll usually tell you down there. Okay. So on my screen there, it's probably a little bit hard for everyone in class to see, but down there, there's a little message there that says starting mechanical. Because a lot of times, you know, the programs in ANSYS kind of take a while to run. So, you know, if you don't see anything down here, then, you know, maybe you can either double click again or just kind of maybe restart the click. Okay. Okay. And so if you open up mechanical, you should see a different window. Okay. But the nice thing is that your geometry should be loaded into ANSYS Mechanical. So you should see your plate with the hole pop up here. All right, did everyone get the ANSYS Mechanical open and has your geometry there? Question? Yes. If you're opening up ANSYS for the first time, it may give you spam and say like like and subscribe our YouTube channel. So if you get that, just you should see something on the left-hand side called outline. Just click on anything there. So click on geometry. It should bring up the room. Yeah, for most of these computers, it shouldn't have that because I taught the undergraduate at BA course, but there may be a random computer or so that where that. Yeah, it only happens first time you open it up. Okay, all right, and so we are now in ANSYS Mechanical. So this is probably where we're going to spend most of our time in ANSYS. And so if you look at the left-hand side of the screen here on the outline, this is almost always kind of a useful place to look because all of the information about your project will be given here. Okay. And this is especially going to be useful, when we start working with assemblies of parts. And so you'll be able to see all the parts here. You'll be able to assign material properties here. We're going to do our meshing here and so on and so forth. So, this project outline is good to be familiar. Okay. Okay. So first thing I'm going to show you is the geometries tab. So if you expand the menu past geometries, you'll be able to see all of the bodies that we have or all of the parts. Okay. So for this activity, we only have one part. We just have the plate with the hole. But if you had an assembly of several different parts, you can actually see all the different parts, separate here. Okay. And this area is where you apply the material properties as well. Okay. So to apply a material property to a particular part, you're going to left click it from the menu, and then you're going to come to the bottom left-hand side of the screen and then assign a material property there. Okay. But for this project, we only have one material. We just have structural steel, and so we don't need to change anything. But starting in activity 2, we're actually going to be modifying the material. Okay. Okay. Next thing we have here is the materials tab. And so if you wanted just a summary of the different materials that you have here, okay. Again, we just have one material loaded, which is structural steel. Oh, questions?
Don't mean the back part too much, but I'll do the mechanical again. When I open it, it's a completely different, like, looking program.
Oh, so you're going to click on, double click on model from Workbench. Yeah. Yeah, if you double click on geometry again, it's going to open up a different tab software. Yeah, sorry about that. Sometimes I get so focused I miss people. Yeah, don't be afraid to shout my name because I sometimes I get too distracted and I don't see people. So if you're raising your hand, I don't see you, just say hey, then it'll catch my attention. Okay, so under materials here, you can see the different materials that you have loaded here. So we have structural steel, and so you can see a summary of its properties like the Young's modulus, the Poisson's ratio, the bulk modulus, the shear modulus, things like that. Okay. For most cases, we only really concern ourselves with these two materials properties here, Young's modulus and Poisson's ratio. Okay. So for a linear isotropic material, that's all you need, but it's useful to know some of the other ones as well. Okay. Question? Yes. Oh no, it's fine. So Pascal and megapascal, they're both the same. So if it's as long as it's 2 × 10⁻11 Pascal, it's fine. Yeah. Okay, so that's the material there. The coordinate systems tab here, there's usually not much to do here because we're not doing any any modeling here, but this is kind of an advanced feature if you want to add some oblique forces if you. Okay, but the first part that we're actually going to be looking at here is the meshing. Okay. So remember, we talked on Tuesday that meshing is a very important part of finite element simulations. Okay, because in meshing, what you're going to do is you're going to be taking your geometry here. I know this geometry isn't too complex of a geometry, but it's still fairly complex. Okay, and we're going to break this up into much simpler shapes. Okay. Okay, so just to show you, what a mesh would look like, let's just put a very basic mesh on this first. Okay. So to put a basic mesh on your geometry here, you're going to right click on mesh, okay? And then one of the third option down here should be generate mesh. So let's go ahead and click that. Okay. And what that's going to do is that it's going to put a very basic mesh on your geometry. Okay. Okay. So your mesh may not look exactly like this. The thing with meshing is that there's some randomness associated to it. So even if you use the exact same settings as someone else, you know, your mesh may look slightly different than someone else's, and that's perfectly okay. That's fine. Okay. And so, you know, if your mesh doesn't look exactly like this, you didn't do anything wrong. That's just how meshing is sometimes. Okay. But you can see here that, you know, after we mesh, we took our geometry here and we broke it up into a bunch of rectangles, basically, little tiny rectangles. Okay. Now, you know, when you're far away from the hole, the mesh is fairly uniform. But as you get closer to the hole, you can see that the mesh kind of deforms a little bit to fit around the hole. Okay. And in fact, you can see some elements here are not exactly rectangles. So we have a couple of triangles here. Okay. We have this kind of, you know, weird looking shape here because it's trying to get around the curvature of the hole. This one looks kind of weird here too. Okay. So for the most part, you know, most of your elements should be about the same shape and about the same size. But oftentimes when you have to get around certain geometries like this, you may get some weird elements, and that's okay. 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 All right. So this is a basic mesh here. So I would say this is not a very good mesh. The reason being that this mesh is very coarse. Okay. Remember we talked on Tuesday, you know, generally the more elements that you have, the more accurate your simulation is going to be. So a coarse mesh like this, you know, probably isn't going to give you the most accurate results. Okay. So let's refine our mesh. And so let's make it so that our mesh has some more elements. Okay. Okay. So to refine your mesh, we need to modify the sizing of the mesh. We want to modify the size. Okay. So to modify the size of the elements, you're going to right click on mesh. Okay. You're going to go to insert, and you're going to insert what's called a sizing setting. Okay. So you're going to click on sizing. And what this setting is going to allow you to do is going to allow you to change the size of elements. Okay. Now, you know, I would say this standard is pretty common in ANSYS. So whenever you want to change something about, you know, your mesh or your boundary conditions, you kind of have to do it in 2 steps. And so step 1, you have to specify which parts of your geometry are you're going to specify that setting to. And then step 2, you're going to specify the actual setting itself. Okay. Notice how in the bottom left here, there are 2 kind of boxes here that are highlighted in yellow. Okay. Okay. So first thing, let's specify the geometry where we want to change the setting. So for this case, you know, we actually want to apply this mesh sizing to the entire mesh. Okay. So you're going to click on your object here, and it should highlight all green. Okay. And so after you clicked on the object here, you're going to go to geometry. You're going to click on no selection here. And what that's going to do is it's going to open up another menu here. So it's going to say either apply or cancel. Then you're going to click on apply. Okay. And so after you do that, you're going to say that, okay, this setting is going to be applied to one face. Okay. And that one face being our entire geometry. Okay. Now for other projects, what you're going to see is that, you know, you can apply certain settings to certain areas of the mesh. But for this case, our geometry is so simple, we're just going to apply it to the entire thing. Okay. Okay. Next thing we're going to do is we're actually going to change the size of the mesh. Okay. So you can see right now the default size is about 30.1 millimeters. So let's make this smaller. So you can change this to anything that you want for this activity, as long as it's smaller than 30, it's fine. So let me change the mesh size to 10. And let's see how that's going to affect our mesh, right? So if you want to use the same as me, you can use 10, but, you know, feel free to use whatever you want. Just don't use something super small. So don't do something like 0.1. Otherwise, you know, your simulation will be running for days. Okay. Okay. So after we change that setting, let's go ahead and generate the mesh again. Okay. And you can see after doing so, our mesh looks much, much better in this case. So you can see our elements are smaller. We have a much smoother mesh. The hole doesn't look, you know, as pixelated as it was before. We actually had kind of a nice smooth curvature. Okay. And so you can see refining the mesh, you know, actually gives us, you know, we can already see it's going to give us better results. Okay. Question? Yes.
The goal is to have as much uniform shape as much as possible during mission.
That is a goal, although, you know, for complicated geometry, that's almost impossible to do. So, in the next few weeks, we're gonna talk about, what makes a good mesh. But for now, something in the ballpark of 5 to 10 millimeters is good. Yeah, question, yes. Oh, I think probably what happened for you is that, it thinks that your mesh is a 3D mesh. And so, you need to go back to Workbench. So you're going to need to close Mechanical. And then right click on Geometry here. And then go to Properties, and you want to make sure that this analysis type here is 2D. Yeah. I'll come check around with you in a bit. Question, yes. Oh, good question. So if you want to change your units in Mechanical, you're going to go to Home up here, and then you're going to click on Units. Okay, so units is in a different spot. That's kind of the annoying thing with ANSYS, that they don't put things consistently in the same place. And then you can change the units here to there's different units for metric and different units for US customary. Okay, but any of the millimeter ones are good. Right, any other questions on the meshing here? Okay, good. All right. One nice thing that you can look at, and in fact, this will be something that you're going to look at a lot in this class, is oftentimes you want to see how many elements are in your mesh. Right? So ANSYS actually automatically computes how many of these little shapes are in your mesh here. Right. So to see how many elements are in your mesh, you're going to make sure that you have mesh kind of clicked here. Okay. You're going to go to the bottom left-hand side of the screen, and you can see there's going to be an entry here for statistics. So let's go ahead and click on that plus arrow. And after you click on statistics, you're going to see two settings there. So you're going to see one entry for the number of nodes in your mesh. Okay. So nodes are these kind of vertices between the points. Okay. So you can see right now my mesh has about 1,875 nodes. And the number of elements is 587. So that's how many little shapes there are. Okay. Okay. And if you want to kind of play around with this a little bit, let me go ahead and change this to 5 millimeters. Okay. So our mesh is going to be even more refined. What you should see is that the number of elements is going to jump up. Okay. So you can see after I change the mesh size to 5, you can see the number of elements is now 2,251. Okay. Yeah, but again, don't go too crazy here. So don't set the mesh size to 0.1, otherwise you may crash these computers, and that has happened in the past. So you want to be careful. Okay. Okay. All right. So when you're talking about your mesh, the sizing is probably one of the more important settings that you're going to do. But there are other settings for the mesh that you can do as well. Okay. So actually, just to illustrate this, let me go ahead and change this back to 10 millimeters. Another thing that you can do for your mesh is that you can actually specify the shapes of the elements as well. Okay. And so to specify the shapes, you can right click on mesh here. Okay. You're going to go insert. And you're going to insert another object here for what's called the method. Okay. So we're going to click on method. And once again, the method is going to ask you to specify the geometry for your setting. So once again, I'm going to click on the entire geometry here, click on apply. Okay. And then from here, you can specify different settings for the mesh itself. Okay. And so probably the only one that you'll be able to see a difference for today is the different method. Okay. So the default method is what's called quadrilateral dominant. And so what that means that it's going to try to produce a mesh that's mainly rectangular or quadrilateral. Okay. You can change this. And so if you want a triangular mesh, you can change the setting for quadrilateral dominant to triangles. Okay. And what that's going to do is that it's going to change your mesh to be all triangles instead of quadrilateral. So I'll go ahead and show you that really quickly. Okay. So you can see now our mesh is completely made up of triangles instead of quadrilaterals. Okay. So let me go ahead and change it back to quadrilaterals, just because quadrilaterals are a bit, nicer in this case. Okay. Because our object here is kind of quadrilaterally shaped. Okay. But in a couple of weeks, we'll talk about the different element shapes and kind of what that actually means for your Okay, another setting here that we'll commonly come back to was what's called the element order, okay? So don't worry about the order just yet. You can go ahead and leave that on the default, but just know that, you know, we can change that as well. All right, any questions on this so far? Okay, good. Okay, 30 minutes. Okay, so in the interest of time, I'm gonna go ahead and move on. There is kind of one smaller thing I want to kind of show here, but we'll come back to it. Okay, so the next thing we're gonna do here is we need to specify the boundary conditions on our mesh. Okay. So if we come back to the project specifications here, we have two boundary conditions we need to specify. We need to specify the fact that the left-hand side of the plate is going to be fixed to a wall. And then on the right-hand side, we need to apply a tensile pressure, tensile force. Okay. Okay. So to apply boundary conditions on your ANSYS simulation, you're going to come to static structural A5. Okay. And just like we did with the mesh, we're going to insert settings here by right-clicking. Okay. So you're going to right-click on static structural A5. You're going to go to insert. Okay. And first thing we're going to do is we're going to specify a fixed support. Okay. So if you read the tooltip for fixed support, this inserts a fixed support boundary condition that prevents a certain geometry from moving or deforming. Okay. And that's perfect. So that's exactly what we want to specify on the left-hand side. So I'm going to go ahead and click on fixed support here. Okay. And then let's go ahead and apply it to the left-hand side of our geometry. Okay. So you may have to rotate it just because it's a very thin line here to click. Okay. And by the way, if you're having trouble clicking on that line there, you may have to change the selection mode of ANSYS. Okay. So in this particular case, we want to click an edge. So you want to make sure you're on edge selecting mode, okay? Or you can hit Control E on the keyboard. Okay? And then mouse over that edge. And so when you click on that edge, it should highlight green. Make sure you just catch that edge, okay? And then hit Apply in the bottom left. Okay. All right, so that should specify that you want your simulation to be fixed on the left-hand side. Next thing we want to do is we want to insert a load. So we want to make sure we insert our tensile mode here. Okay. Coming back to the project specifications, we can see our pressure has a magnitude of oh, actually, I think that's a typo there. It should only be 1,000 megapascal. So if you come down here, oh, I didn't fix this. Okay, so the pressure should only be 1,000 here. I apologize. I'll upload a fixed version. Okay. Okay, so let's go ahead and apply that pressure there. Okay, so to apply a pressure boundary condition, let's right-click on static structural A5. Once again, let's go to insert, and then we're going to go to pressure. Oops, I did that really quickly. Okay. So right-click static structural A5, insert pressure. Okay. What that's going to do is it's going to create a pressure object here. And so just like we did with the meshing settings, we're going to specify the part of the geometry. So we're going to apply this on the right-hand side of the plate. So go ahead and click that edge, hit apply. Okay. Question, yes.
I think the loading is correct. You have 1 times 10 to the 4th here on your activity.
Okay. Okay. Oh, that's good. Yeah, I just yeah, it should be 1 times 10. Yeah, it should be only 1,000. It's only 1,000, but so 1,000 is 1 times 10 to the 3rd. Okay, so for the magnitude for the loading here, let's go ahead and specify 1,000 megapascal. Okay. You can do 10,000 if you want to. It's not going to change the result all too much. Well, it will. All your deformation will be 10 times greater. But 1,000 is good for this. Okay. Okay, and if you want to see a summary of the boundary conditions, you can come back and click on static structural A5. And you can see here we have our 2 boundary conditions specified. So on surface A right here, okay, you can see here that we have our fixed support. Okay. And then on surface B, we have our tensile pressure of 1,000 megapascal. Okay. All right. Any questions on this so far? Everyone able to apply the boundary conditions? Okay. All right, and so now that we have our mesh, now that we have our boundary conditions, we are ready to solve. But before we solve, we want to specify our output fields, okay? So before you run the simulation, go ahead and right-click on solution A6. You're going to go to Insert, okay? So you can see here there's lots of different results that you can show for any given finite element simulation. But for this one, we're just going to keep it simple. And so the two results that you're almost always going to view in this, for this class is going to be the total deformation. So you're going to right-click on solution A6, go to Insert, Deformation, and then click on Total. Okay. And the other one that you're going to specify is the equivalent stress. And so you're going to right-click on solution A6, go to Insert, Stress, and then you're going to go to Equivalent von Mises stress. Okay, good. Okay, so after you specify those two output variables, let's go ahead and solve. And so to solve your simulation, you can do it a few different ways. You can right-click on static structural A5 and solve. For me, I like clicking on the big glowing button, so I'm going to go ahead and do that up here. Okay, so there should be a button with the lightning bolt that says solve. So go ahead and click on that. Okay. So that's going to go ahead and solve your simulation. It might take a couple a minute or so, maybe about 10 seconds. Okay. All right, and so that is your simulation result. Okay. And it looks actually kind of scrunched up. Actually, let me see. Oh, interesting. It's applying a compressive force. Okay. All right, and so that is your simulation there. So, you can view the total deformation field. You can view the equivalent stress field. Okay. And you can see those, once again, like I told you, like we talked about on Tuesday, the colors here indicate the magnitudes of those results. Okay. So for the red areas usually indicate the highest value. So the red, that has the highest values of deformation, and it goes down to blue. So you can see the deformation here varies from 0 to about 1.68. Okay. And the equivalent stress, the maximum equivalent stress here is about 3,327 megapascal. Okay. Okay, was everyone able to get results here? Okay, good. Okay, so actually let me correct this real quick because the result should be tensile, and I think I actually know why. I kind of skipped ahead in the document here. Okay, so right now our pressure is being applied compressively. Okay, so it's actually applying like this. Because usually when you apply a pressure boundary condition, the default is to make sure that the pressure pushes into the model. Okay. So to make sure the pressure actually goes out, you can actually do this in one or two ways. Okay. And so to change the direction of pressure, you can go ahead and click on the pressure boundary condition here. Okay. So after you click on that, you're going to go to the bottom left-hand side of the screen. You're going to go to the define by setting here. Okay. Right now it's defined, right now the direction of the pressure force is defined as being normal to the surface, okay? So let's go ahead and change that to components, okay? And so if you change it to components here, you can actually specify the X component and the Y component of the pressure, okay? So actually let's change the X component of the pressure to a positive 1,000, okay? And so what that's going to do is that it's going to apply that pressure in the positive X direction. Since we're now applying it by the component. Okay. So let's go ahead and run the simulation again. And what you're going to see is that now our plate should be deforming in a tensile manner. Okay.
So,
yeah.
When I changed it to normal to, did not get the option.
You should change it to components.
Oh, here.
Yeah. So instead of so normal to was the default, and so you should change it to components instead. Yeah. Mm-hmm. Thank you. Mm-hmm. Okay, and so now you can see now our plate is being appropriately kind of stretched out. Okay. And then that's what our equivalent stress field kind of looks like. Okay. All right, any questions on this? Okay, all right, so that's most of the activity there. And so let me go ahead and show you what you need to do for the rest of the time. So there's about 20 more minutes left, okay? So if you come down to the bottom of the page here, we've basically done everything from pages 1 through 17. Okay. So what you guys need to do here is everything down here. Okay. So you can see I've split your activities into problem 1, problem 2, and problem 3. Problem 3 is just some short answer questions that you can answer on your own. Okay. But the main thing that you need to do here is problem 1 and problem 2. Okay. So first is problem 1. So problem 1, I want you to look at your results here and kind of interpret what's going on. Okay. And so I want you to answer this question of, what's the maximum deformation or the maximum deflection in the plate? Where does it occur? I will also want you to answer what's the maximum stress in the plate and where does it occur? Okay. And for this question, I also want you to include a screenshot of your deformation and equivalent stress plots. Okay. So basically a screenshot of your deformation plot. So just take a screenshot of this, screenshot of your equivalent stress field. Okay. So that's problem 1. So, you've pretty much done that already. You just have to answer these questions. Okay. For problem 2, I want you to kind of experiment and change a few of the settings and see how that changes your results. Okay. So for problem 2, part A, I want you to change the loading. So I want you to change it from 1000 megapascal to 2500. And you're going to answer some questions associated with that. Okay. Part B, I actually want you to go back and change the geometry. So I want you to change the size of the hole. Okay. So the default right now is 50 millimeters, but if you change it to 125, I want you to see how that changes the results. Okay. Part C, I want you to change the mesh size. Okay. So I want you to run a simulation with a 2.5 millimeter mesh and a simulation with a 10 millimeter mesh. Okay. And again, answer some questions associated with that. And then part D, I want you to change the shape of the element to triangles. Okay. So if you remember, from earlier today, if you go to the method object under mesh, you can change the method here to triangles. And so I want you to kind of run a simulation like that and see how that affects your results. Okay. All right. Any questions on that? Okay, so you guys can go ahead and work on that for the rest of class today. So if you're having issues or you're having questions, just raise your hand. I'll come around. But that's all that I had planned for today. So actually before, very last thing, I'm going to go around in a bit, but before I go at 6:45, I'm going to show you how to export your project. But, let me go ahead and answer questions first. And I should work on it in a bit. Then we'll. Okay. So if you have questions on the project or if you're not getting it, just raise your hand. I'll come to you.
Yeah.
Yeah, I think probably.
I get this thing on the beach, bro.
Yeah, because I don't think it's that big. The one thing for the model. Yeah, do that.
Yeah.
Very small, very. That's normal.
Oh, yeah.
Most part, it should be very.
I did not get this.
Well, it should be done. So the lower down, I think it might be something. But the most part, this week,
Oh, wait,
I mean, we don't.
Huh?
Oh. Which is something we're talking about. If you actually hear the accent, actually, that's
Yeah, that's fine. I was in the thought. I'm gonna throw them. Like, actually, no, oh, wait, I turned off my color. Right last week. That's all I do. You did it right the first time. Perfectly right. Am I supposed to grab the actual like part of it? Well, I grabbed the edges.
Spell now?
Why should I take a peek real quick? Just like stick it on there. How did you do
School resource now.
Put on my resource, my source, my paper. I feel like last time we did. No, last time you read it. Oh, no shit, bro. I'm sorry. I'm getting.
I don't think it goes all the way.
So, when you have nations, you see that, okay, no, you're on phone. You're putting stress, or like you're managing.
Yeah. Yeah, I was telling them too, but the stress is actually very sensitive. So actually for you guys, I see that, fine. So I was debating whether to show that today, but I'm kind of out of breath, honestly. So I kind of held off for now. We'll hold that discussion for a bit, but yeah, the stress is actually very sensitive. What you guys have was refined, and it looks like your base mesh is actually smaller than mine too. It's gonna need.
Okay.
Yeah. All right, so this is more.
Okay.
I'll trust this.
All right, appreciate it. Oh, and when saving the file, like take it home.
Yeah.
Can we just save it the W whatever.
Yeah, we have to export, so I'll talk about it at the very end. Yeah.
Okay. Alright, here's the next question now. So just.
How do you get down?
No, but we still with the 10,000.
What?
Yeah, so there is a
Person is
difference.
1,000.
So we're actually running this.
How much did you go from
system
1,000
So actually the model was started.
Oh.
Okay, but the thing is that you assign is actually kind of like a
subsection.
parameter.
You just
So
say
it's like there's
10,000,
two-
45,000 for
it's-
new subset.
For that thing, it's actually added to these. Yeah, but if you actually run this at the.
What do we do here?
3D with a thickness actually part of the model. And
How do you do
that's-
it? Split?
This method is just a lot cheaper.
How do you like
when
take
you do it
Oh,
through
print screen.
Images.
Exactly, yeah. So we'll actually talk about this activity. So actually, so technically, what we do there is it's a shell model.
Okay.
So a shell model, kind of like a two. And this actually sounds like, this actually technique that you play around with very thin geometry. It's just way cheaper.
Yeah, so it's put it one click and it was.
Exactly, so, yeah.
But that's for, so let's say it's like this, you should take it home.
Yeah.
So once we save it at home, this will become like 30.
Yes. Yeah. Yeah, great.
Like, give me your.
So you have to be, it's only, it's a one-way. So you can upgrade, but you can't downgrade.
Okay.
So the activity is doesn't matter too much, but generally, you can just take a screenshot and just show the number bar.
I don't know, color ones.
See, that's why
Oh,
I
yeah.
did it correctly.
I messed it up.
Did you? You see, I did this.
Yeah.
I just gotta give up. I don't know. I never like stop having, I kept messing with it and it just stopped talking.
Yeah.
Yeah, the thing part, it's actually got several different kinds yeah, but actually, out of the third, that was actually when I wrote it.
Yeah, it is just better. Come on. You know, I'm sure a couple of months, because it's French, so we have like a dinner. Something like a catering. That's me. Right now, the passes started reaching my hand. He went.
Dude, I don't even know what's going on. I didn't open it.
You be crazy there, bro. Just
Oh. I think it's blowing up. I didn't open this. I think I know the last time. I did it at home.
Look, if I work, like, no, special things.
Maybe I'm not sure.
What are you doing? There you go. He's a little.
Just redo it at home.
That's right, dude. Can I not edit this? Very simple. You don't, it's not like. I'm not sure. What the heck? There's no detail.
Okay, so really quickly before everyone heads out, I do want to show you how to export this back home. Okay, so to export it, I'm gonna go ahead and close mechanical here. Okay. Make sure you save your project. So you would think that, you know, when you save the project, ANSYS would just give you one file to send home. Unfortunately, that makes too much sense for ANSYS, so it doesn't actually do that. So actually, if you go to where you save your project, you'll see that ANSYS actually saves a file and a couple folders here. And so there's one file here and then this folder, which actually contains the actual files. And so, you know, you cannot actually move these folders and file back home. And so what you actually need to do is you need to zip it into a single package and send that home, okay? So to actually package it as one file, you're going to go to File back in Workbench and click Archive, okay? And then what this is going to do is it's going to save another different file called a WBPZ file, okay? So go ahead and click Save. For some reason, it already exists. It might be the one I did last semester, okay? And then another menu is going to come up. You click Archive. Okay. And you go back to the folder here. I'm sorry. I think I archived in the wrong folder. Let's see. Oh, it literally is the one I made last semester. Okay, so let's go to Documents here. Archive. And you go to that file location. So now you see there's a file with an extension WBPZ. And so that Z is important. So if you want to work on this back home, this is the file that you actually move. So you just move this one file. And then when you open it up on your home computer, you just double click this and it'll open up in ANSYS for you. Okay. All right, so that's it for today. And so I'll stick around if you have any more questions, but thank you guys for coming today. This is always the most hectic one. This is the one I get most out of breath for because there's so much to say. But you know, we'll be doing a lot more ANSYS this semester. So thank you guys. Hope you guys have a good weekend, and I will see you guys next week. Thanks, guys. Yep.
We're gonna, oh my God, I just lost it. What are the three different options? I know you said there's like 4 different programs.
Yeah.
What are the three different options?
So-
Just like a geometry.
So I'm embarrassed to not know this, but this is my theory, is that ANSYS is run by a company called Simula.
Yeah.
And so I think they're trying to create a monopoly on the whole FDA modeling thing. So anytime someone comes up with a program that's like kind of competitive, they just buy it and it's added in.
Oh, like, yeah.
Because yeah, I was telling the guy back there, like there's like 4 programs for CFD. There's no reason for 4 programs, and there's 3 CAD softwares, and they only do like slightly different things from each other. So
I've seen Fluent being used a lot for CFD.
me too. Yeah, that's the one I'm mostly familiar with.
Well, I got a question, just a general question.
Mhm.
I'm thinking about senior thesis.
Okay,
Project,
yeah.
Something. I like vapor, you know what a vapor chamber is?
Oh, what is it again?
It's just like it's a 2-phase, like a heat exchanger.
Okay.
So I just have a bunch of like, it's just like water,
Yeah.
and then like a heat pipe basically. As something gets hot, the water boils up, can get to the top, it falls back down. It's just like a
Okay.
way to evenly disperse heat. I think Fluent's pretty good at like 2-phase simulation.
It can do.
It can.
Whenever you have multi-phase flow, though, it's very expensive.
Oh, okay.
Because you constantly need to check, what phase this matter as it goes. And you need to simulate the fluid flow and the heat transfer.
Yes.
And you have phase changes. So that,
Okay, it's
yeah,
pretty expensive.
it's pretty expensive. But I'm pretty sure ANSYS can do it.
Okay.
I've seen the settings in Fluent where you can do multi.
Oh, okay. And also there's a lot of capillary action happening like before it's like a censored
Sure.
weight, a
Yeah.
force medium.
Yeah,
For this is very general. I can figure out later, but
yeah.
in SolidWorks, like if I was modeling on SolidWorks, would I just make like a solid body and then assign like a porosity to it and like
That's probably most likely what you,
Okay.
so actually, like geometrically modeling all the floors.
yeah, that sounds awful.
It's not feasible.
Yeah.
So yeah, you'd have to model it and you'd have to give it some either uniform porosity or.
Okay, that makes sense. And then I can just find if I can just find like a general porosity with a censored weight. Okay. that
Yeah,
makes sense.
but then that would be another thing you'd have to simulate, because that's also mass transfer with, so, yeah.
Okay.
I mean, it's possible, it's just
Yeah.
expensive.
Yeah, that's what I was thinking. It's interesting. I like the chamber.
Okay.
So.
Do you have an advisor for it?
Talking about the bench right now.
Okay, I was gonna say Dr. Ben. Perfect.
Oh, yeah, okay, cool. Waiting for him to get back.
Okay.
Thank you, I really appreciate it.
Yep.
There you go.